Hi friends, in this video we will go to see Z parameters. In this series of lectures we will discuss about network theory, and from here we will go to see what are the circuit parameters. There are so many circuit parameters are there: Z parameters, Y parameters, ABCD parameters, H parameters, like that. In this video we will discuss about Z parameters. Z parameters, here Z indicates is nothing but impedance. Impedance parameters is also known as Z parameters. These parameters are used to find the input impedance, output impedance, and there is any circuit impedance in between the input and output in the network of two port. Okay, that type of parameters can be calculated by using Z parameters. Okay, here let's see the line. Z parameter is also known as impedance parameters. As we already discussed, Z parameter is also known as impedance parameter. Z parameter describes the impedance of two port network. We already know what is two port network. Okay, two port network means there is two ports, that means there is two ends. In two ends we are applying voltages, and that type of network is known as two port network. The Z parameter describes the impedance of two port network. This step means the Z parameters are used to calculate the impedance of the two port network. Here observe, here we have Z11, one impedance is there, Z21, Z12, Z21. Okay, we can represent Z12 and Z21 as a single resistor, or you can draw two resistors parallelly. Okay, that's also a similar way of representation. Here observe, Z parameter describes the impedance of two port network. By using the Z parameters we can find Z11, Z12, Z22, Z2, Z21, Z22. Okay, here Z11 is nothing but input impedance, because this is present in the input port. This is input port. Let's see, this is input port, this is output port, and the voltage between these two terminals is V1, and current flowing is I1. Here current flowing is I2 and voltage is V2. Okay, this is input port. Input impedance is Z11, output impedance is Z22, and in between input and output we have some network impedance, we can call that like that. That is nothing but Z12 and Z21. Okay, here let's see this point. It is used to describe the small signal response of a non-linear network. This point states that if we apply the small signal is nothing but if a signal having low voltages and low frequencies, then the signal is called as small signal. If we apply small signal to as input of any two-port network, then the response is calculated by using the Z parameters. Okay, next, by using Z parameters we can calculate Z11, Z12, Z22, Z21, Z22, as we already seen in this circuit. Okay, let's see here. Now we see how to calculate input impedance, output impedance, and in between input and output we have circuit impedance. Let's consider a two-port network like this. These two are circuit impedances, and this is output impedance. This is the two-port network. Okay, and the voltage applied between the input terminals is V1. Voltage applied between the output terminals is V2, and the current flowing through the input port is I1, and the current flowing through the output port is I2. Let's consider this is Z11 and this is Z22. This is input impedance and this is output impedance, and in between input and output impedance we have Z21 and Z12. Let's consider this is Z12 and this is Z21. In most of the cases Z12 is equal to the Z21. First, we have two standard equations for Z parameters for finding the unknown voltages or currents. Unknown voltages, current is nothing but input voltage, output current, and input current, like that. Okay, here see, V1 equal to Z11 I1 plus Z12 I2 and V2 equal to Z21 I1 plus Z22 I2. Okay, these are the basic equations for Z parameters. From these equations we can calculate the Z11, Z12, Z21 and Z22 values. Let's suppose assume I2 current is 0. In this equation, in this first equation, let assume I2 current is equal to 0. Then the complete term will become 0. Then V1 equal to, we have only Z11 I1 itself, because this already, this term is 0. Okay, assume only, this is only assumption. I2 equal to 0, then the complete term will become 0. Then only we have V1 equal to Z11 I1, that is V1 equal to Z11 I1. From this equation, Z11 equal to V1 by I1. When we get the V1 by I1, when I2 equal to 0, remember this point, when I2 equal to 0. Okay, likewise, if now consider I1 equal to 0 in this equation only. I1 equal to 0 means this term, this complete term will become 0. Then we have only V1 equal to Z1 to I2. V1 equal to Z1 to I2. From this we can calculate Z12 is equal to V1 by I2. Okay. Here we can we are calculated Z11 and here Z12 equal to V1 by I2. When we get the V1 by I2 for Z12 means whenever I1 equal to 0. That's what we mention, I1 equal to 0 here. Okay. Now we will find the values of Z11 and Z12. Here remaining two terms are missed. Thus two terms are Z21 and Z22. Z21 and Z22 are calculated by using this sequence, the second equation. Now let's again assume, like first equation only, assume I2 equal to 0. If I2 equal to 0 and the entire term will become 0, then we will have only V2 equal to Z21 I1. From this, Z21 equal to V2 by I1. When we get the V2 by I1 means only when I2 equal to 0. Okay, we get Z21 value also. Now assume I1 equal to 0 in V2 equation. I1 equal to 0 means the complete term will become 0 and we can have only this 2. V2 equal to Z21 I1. Okay, Z21 I1. Sorry. If I2 equal to 0, if I1 equal to 0, we already get the value of Z21. Now we no need to require Z21. So now we need to calculate the value of Z22. That's why we simply assume I1 equal to 0. That's whenever I1 equal to 0, this total term will become 0. Then we have the equation V2 equal to Z22 I2. From this, Z22 is equal to V2 by I2 when I1 equal to 0. This is how to find the Z11, Z21, Z12 and Z22 values in Z parameters. Thank you for watching this video.